Welcome to this presentation on Gaussian process classification. In this session, we'll explore how to predict the earthquake alert levels using the Scikit machine learning tool. Our focus will be on understanding how Gaussian process classifiers work and why they are particularly effective for small datasets. We'll go step by step, starting from pre-processing and data preparation, then discussing the structure of our earthquake dataset, explaining the Gaussian process model, and finally reviewing training, prediction, and evaluation results. Before training the model, we first pre-process the earthquake classification dataset to make it compatible with machine learning. The dataset originally included 5 numerical features: magnitude, depth, CDI, MMI, and SIG, and 1 categorical features, alert. Since models can't interpret text directly, we used label encoding to convert the alert levels, such as green, yellow, orange, red, into integer values from 0 to 3. Once encoded, we divided the data into 80% for training and 20% for testing. This ensures that model learns from the most of the data, while still allowing us to objectively test its accuracy on unseen examples. This dataset captures real seismic events and the alert levels associated with them. It contains 1,300 records and 6 total columns, 5 numerical features, and 1 categorical target. Each row represents one earthquake, describing its physical characteristics such as magnitude and depth, along with its reported intensity through the CDI and MMI features. The significance score SIG summarizes the overall impact. The target variable alert indicates the final issued alert level, green for minor events, yellow and orange for moderate to strong ones, and red for severe cases. Together, these features provide a rich basis for modeling how physical and perceived intensity translate into real-world alert categories. The Gaussian process classifier, or GPC, is a probabilistic non-parametric model that defines a distribution over function instead of fitting a single fixed curve. It uses a kernel function, typically radial-based function, RBF, to measure similarity between data points and capture smooth, nonlinear relationships between features and labels. One of the major strengths of GPC is its ability to estimate prediction uncertainty, meaning it doesn't just predict an alert level, it tells how confident it is of that prediction. This is especially beneficial for our relatively smaller dataset, since GPC naturally handles limited data without overfitting. By leveraging the flexibility of kernel methods, the model generalizes well while maintaining interpretability, make it ideal for scientific applications like earthquake alert prediction. After pre-processing, we train the Gaussian process classifier using 80% training subset and evaluate on the 20% test data. The model predicts most likely alert class for each event based on the learned relationship between seismic features and alert levels. We assess performance using the F1 score, which combines prediction and recall into a single metric to measure how well the model identifies each alert level. A higher F1 score indicates better overall classification, capturing both accuracy and reliability. Through this experiment, we see that GPR can deliver consistent, interpretable result, even with a relatively small dataset. Now, let's move on to our Scikit machine learning online tool implementation. First, let's name our project here, and then let's write a brief description of our project. Then in the data section, let's choose the data type. Our data is in the CSV format, so let's choose the tabular. And then let's upload our data. So after successfully uploading the data, we can see the summary of our dataset. This table shows all of the columns, and if we want to see more rows, we can just click the Next button. And in the Data tab, we have the summary of our data, such as unique values, data types, etc. Now let's choose our target label, which is the alert. And then let's choose our machine learning algorithm. We will be using the Gaussian process classifier here. And then let's choose our evaluation metric, which is the F1 score. Let's click Perform. After a few seconds of processing, we can see our final result is here. The F1 score equals 0.92, which means our model was able to accurately predict the result with such a smaller dataset that only has 5 input features and around 1,000 rows. Thanks for watching.